The desire for exploration and adventure is fundamental to the human condition. We are not very good at staying in one place. We never have been, from the first primitive migration across the continents to sailing ships to airplanes to rockets. We are constantly in search of the next great journey. And over the past 100 years, we've gone to extreme and incredible places. The South Pole, the bottom of the ocean, the moon. But another great journey still awaits us from the Earth to Mars. Given our history, it's no surprise that Star Trek was the first science fiction to take over the mainstream consciousness in the 1960s. A crew of brave adventurers in an amazing spaceship that allowed them to boldly go where no one had gone before. Now we're not quite there yet, but NASA does have a plan as of right now for how they are going to get the first humans to the surface of Mars and then get them back home again safely to tell the tale. And here is how they're gonna do it. The first step in the process of reaching Mars is a big one. We have to establish an advanced and permanent presence on the moon. It might not seem like a big difference, but going from the moon to Mars will be a lot easier than going Earth to Mars direct. The Earth's gravity and dense atmosphere make it a nice place to live. But these factors also put a hard limit on how much stuff we can launch into space. At one time, the moon presents neither of these problems. It's going to be much more difficult to sustain life up there, but if we can figure it out, then the moon becomes an ideal spaceport, a gateway to the solar system. And this is the long-term goal of NASA's Artemis program. They're not just going back to the moon to plant another flag and stick it to the communists again. I mean, they are, but they're going to do other stuff after that. The Artemis missions 4 through 10 are going to be all about learning to live on the moon. That means in situ resource utilization, finding their own water and oxygen using the rocks and metals already present on the moon to start building new infrastructure, and at the same time, NASA and their partners will be creating the Lunar Gateway Space Station, a deep space outpost on a new frontier, as NASA establishes their human presence on the moon and in CIS lunar space. They will be simultaneously expanding their robotic presence on Mars. That means new rovers for sure. But the most exciting prospect for the next 10 years is the large-scale deployment of flying machines on Mars, with the widely successful first test of the Ingenuity drone over the past year. We've now confirmed that we can fly helicopters on Mars. This opens up a whole new potential for exploration and sample collection on the Red Planet. NASA even has a plan to deploy an autonomous space station to Mars orbit, acting as a more permanent way station, not just for missions going to Mars, but also for the return trips. A big part of the next phase of Martian research is going to be sample return missions. No more one-way flights to Mars. That is the essence of NASA's Moon to Mars plan. We establish our foothold on the moon. We learn how to survive and build in the harsh environment of a lifeless world. At the same time, learn as much as we can about the planet Mars. And we put down a robotic foundation for the first people to arrive with all of that in place. We are finally ready. So let's go to Mars before people even arrive. There will be one or more supply drops to make sure that everything these astronauts will need to survive and then return home is already there and waiting for them. This begins on Artemis 10. In addition to a lunar surface mission, this flight of the SLS is slated to deliver a payload called Mars Cargo Stage 1 to lunar orbit. Artemis 11 is the same deal. There will be a lunar surface mission and the deployment of the Mars Cargo Stage 2. The pre-deployed cargo will arrive on a 25-ton Mars lander that will contain propellant for the return ascent. It will contain a power source for the crew and mobility equipment. There will also be a pre-deployment ascent vehicle on the surface of Mars prior to the crew's arrival. Artemis 12 is going to be a big one. This is when the Mars 1 human lander with surface subsystems and the transit. And easier both NASA and DARPA. During this time frame, the Gateway will have a crew of 4 operating for 134 days at a time. NASA plans to use the Gateway station in orbit around the moon as the send-off point for the crewed mission to Mars. This transit HAB ship with the Mars 1 human lander will depart from the Lunar Gateway and probably make their return there as well. The main event will be 2 astronauts landing on Mars in a pressurized vehicle that will serve as both a habitation module and a rover vehicle. This will be their home for 30 days on the Martian surface and will support their science and exploration operations. It is important that the habitat double as a transportation vehicle, because even in the reduced gravity of Mars, it will take time for the crew to recondition their bodies after months of zero-gravity spaceflight. It will probably be a few days before the crew have regained the strength to be able to put on their spacesuits and even walk on the surface of Mars. So it's important that the habitation module doubles as a rover so that they can get straight into their exploration mission without missing a beat. To get people from the Earth to Mars, NASA will develop a transit habitat that employs a hybrid of both chemical and electric propulsion stages. This will support a crew of 4 on the mission to Mars and back again. 2 crew remain in orbit for the full duration, while 2 go down to the surface. As for landing on Mars, things get a little bit tricky here. Let's look at how NASA landed their most recent Perseverance rover on Mars. It was a pretty intense process. First, they entered the Martian atmosphere in a capsule very similar to how we get people back to Earth from space. Mars has a very thin atmosphere, but it's still enough to require a heat shield to protect the craft from burning up after punching through the upper atmosphere. Perseverance deployed a giant parachute to slow its descent while the capsule autonomously identified a landing site and maneuvered in using gas thrusters. Here's where things get kind of crazy. The Mars atmosphere is too thin for the parachute alone to provide a soft landing, so the rover had to drop the capsule with essentially a jetpack strapped to it. Now it becomes a propulsive landing with these little rockets slowing it right down to a hover, and then the jetpack becomes a crane, and it slowly lowers the rover down on a wire and places it gently on the surface. So however NASA decides to land the crewed vehicle on Mars, it's going to be a wild ride. There are 2 mission profiles for going to Mars. One is a short stay and the other is a long stay. For the short stay mission, the outbound period will last 217 days and utilize a gravitational assist around the planet Venus to boost the spacecraft on its way. The stay on Mars will last for 30 days, and the return trip will be a grueling 403 days in deep space. That will suck. But it's likely safer than spending an extended period on Mars that adds up to a total mission duration of 650 days. For the long stay mission, the outbound period will be 210 days on a direct course from Earth to Mars. No gravitational boost required to stay on Mars in this scenario will be 496 days. So this is a significantly longer mission and will require a lot more planning and pre-deployment. And then the return window is shortened to 210 days because the crew will be taking advantage of an ideal transfer window. Now it's also important to keep in mind that this plan is based on technology that we have available right now. But NASA is working on a next-generation propulsion system that would make the transit to Mars and back again significantly faster and easier. Both NASA and DARPA, the Defense Advanced Research Projects Agency, are set to perform a scientific fusion dance that will result in the first ever human spacecraft to be powered by a nuclear thermal rocket engine. The NASA-DARPA partnership has been named the Demonstration Rocket for Agile Cis-Lunar Operations, which has mercifully been shortened to DRACO, compared to the performance of a chemical rocket engine used in the vacuum of space. The nuclear thermal rocket should provide somewhere between 3 and 5 times greater efficiency, and that is going to translate to a spaceship that can travel faster, carry more payload travel further distances, and maneuver through space much more quickly and easily than any vehicle we've used to date. In practice, that can mean reducing the transit time for a crewed mission to Mars from as long as 8 months to as little as 45 days. The longer a crew spends in transit, the greater the risk they will face, including but not limited to the potentially deadly cosmic radiation. Likewise, the longer a crew has to live in the vehicle, the more supplies like food and water they will need to bring with them. And when we're talking about spaceflight, every single ounce of mass that you carry with you is important. DRACO is expected to come online in a relatively short time frame, less than 5 years from now. So that would imply that these agencies are pretty confident that they have this figured out, and that means that it is pretty likely that the nuclear engine will be ready to go in time to build the first Mars transit habship, assuming that's probably 10 years away or so. Of course, anyone who follows the spaceflight industry knows that nothing ever happens on time, and every project will always be behind schedule. But it's much more fun and satisfying to think about these things through the lens of eternal optimism. Human beings have a long track record of accomplishing anything that we put our minds to with sheer will and determination, and the human spirit refuses to stay in one place for too long. So we are going to Mars. The journey is in our nature.